I'm going to talk about how to graph a sequence or a series, and I'm going to change a little bit what we had said in class. So suppose you wanted to graph a series, and I'm going to pick one from the homework, something like, let's say 9b. I'm going to try to graph 3 over n plus 2. So once again, I am in sequence mode. You can see that right over here. And when I go to my y is equal to, this is a little surprise here, I'm just going to type in my function. So that's 3 divided by parentheses n plus 2. And n min is 1, and u of 1 is, let's see, that would give us 1, right? 3 over 3. So when I go to look at the graph of this, I'm just going to check my window. Let's suppose, I don't know, maybe I'll arbitrarily look at 15 different entries. So x max maybe will go to 20. And I'm assuming that this is going to converge to 0. So I'm going to stay with y max is, 1.5 and look at the graph of this. And sure enough, when I trace over this, the trend is the terms all seem to get closer and closer to 0. And if I wanted more proof, I might make n max equal to 50, which means x max also has got to be, let's say, 51. So I see this. Now I'm looking at a whole lot more points, and I can still see that these get closer and closer and closer to 0. If I want to graph a series, on the other hand, something like, in fact, I will look at the harmonic, that we know that, in fact, this does not converge. So this is a change from what I mentioned in class. I'm going to go to y is equal to. And what I had said in class is what you want to do is type in your function, and then you can always do plus second u of n minus 1. And that, in fact, might be the easiest way to do a series. Just always add the previous term. Here's something else that you could do. The other thing we could do is you may have sigma notation on your calculator. And again, I never know where to find it. So I always have to go to the catalog, and then I know this is in alphabetical order, and I do not feel like scrolling down until I get to S. So I'm going to go directly to the T, and my T is above my 4 right there. So I'm just going to press T, brings me to tan, and then prior to that I have summation. So I'm going to press enter, and now n is going to go from 1 to n. Right? We want a variable there because we're trying to plug in a lot of different x values, and then I'm going to take the sum of, I'm going to do harmonic, okay, and u of 1, in fact, is going to be 1. So now when I look at the graph of this, let me just check my window. Okay. Well, I'll look at 50 ordered pairs, but I think my y max is going to have to be bigger. Let me make my y max 20 arbitrarily. And when I look at the graph of this, okay, it seems to me as though this is never leveling off. If we trace over this, it seems to me this is more like a natural log function rather than something with a horizontal asymptote. And you can see it always sort of bumps up a little bit. So this does not converge. On the other hand, if I wanted to find the sum of, let's say, 1 over n squared, I'm just going to go back to my summation, and I'm just going to edit this a little bit. 1 over n squared. Let's look at the graph of that. I'm going to stop this. I'm going to make my window a little bit shorter. I have too much room on the top. So I'm going to make my y max 1.5. Yep, bad idea. I'm going to make my y max 10 and see what that looks like. This looks more like we have a horizontal asymptote here. So my guess is it looks like this converges. So I hope that helps you in doing your homework.